Hello class, this is a video tutorial on series and recurrence relations. A recurrence relation is an expression where the next term is found by resubstituting the current term into the relation. It is often expressed as t of n plus 1. So the next term, because if we're on t1, to find t2, we substitute 1 into of n, so you get t2 is equal to some function of t of n, where t of n, notice how this is the next term, and this one here is the current term we're in, and we must always be given, it's often, the first term, so we have to be given some term to work with to start from somewhere. And this is kind of redundant, it's always assumed that n must be whole numbers of 1, 2, 3, and so on. So here are three examples. T of n plus 1 is equal to t of n plus 3, and the first term is 1. Another example, t of n plus 1, so the next term is equal to 2 times of t of n, where t of 1, so the first term, is 3. And I'm sure you get the idea. T of n plus 1, so the next term, is equal to 3 times t of n plus 1, and the first term is 5. So these are just examples, but I'll demonstrate to you how you would use them, and to get a better understanding of how they operate. So let's write down the first 4 terms of these recurrence relations. So what I'm demonstrating to you now is very much overkill, so you don't need to write down t of 1 with the underline and so on, but I'm just demonstrating this to you to get your head around this. So let's take a look. So we already have t of 1, it's 2. But now, using the recurrence relation, if I want t of 1 plus 1, which is 2, I need t of n, which is the current term, so I'm resubstituting the result of 2 back into the relation, then I'm adding 4. So t2 is equal to 2 plus 4, which is 6. And now if I want the next term, if I want 2 plus 1, that gives me the third term. Well, the third term is found by resubstituting 6 back into the relation and get the result. 6 plus 4 is 10. To get t of 4, so the next term, I need to substitute t3 back into the relation. So substituting 10 back in, we get 14, and so on. So I hope that gives you already an idea of how a recurrence relation works. Whatever number you're on, resubstitute it to get the next term. Here's another example. So for this, we already have the first term, t of 1 is 2. To get the next term, so 1 plus 1, we get t of 2. But to get t2, we get the first term and resubstitute it back into the equation, and then we evaluate that. 2 times 1.5 is 3. Taking that result, substituting it back in, gives us t3, which is what we want. So substituting that back in, 3 times 1.5, I believe, is 4.5. And then resubstituting that back in to get t4, so substituting this back in, definitely can't do this in my head. Oh, and obviously you can always do this as a fraction, so just leaving 4.5 as 9 over 2, whichever you're most comfortable with. This will give us 6.75. And the cycle continues, but this question only wants us to get the first 4 terms. And I hope that pretty much summarizes the rest. I'm just going to do the next 3 examples. You can pause the video and try it yourself, or move on to the next bit. So here we go. For this one, we already have the first term, which is 0. To get the next term, 0 substituted back in. 2 times 0 plus 4 is 4. To get the next term, we take 4 and re-substitute it back in. 2 times 4 is 8, plus 4 is 12. Substituting 12 back in, 2 times 12 is 24, plus 4 is 28, and so on. Moving right along. Oh, this one's a lot more difficult. We have the first term. It's going to be 4. Substituting 4 now, being very careful here. 4 divided by -2 is -2, plus 1 is -1. Substituting this back in, that's going to be -1 divided by -2. So that's positive half. Half plus 1 is 3 over 2. Just did a little cop out and just use a improper fraction. That's fine. Substituting this back in, it's going to be -3 over 2 over 2. So that's going to be -3 over 4 plus 1. I believe it's going to be a quarter. And there we have it. And so on. Now, this one here, I've left to the end because now there is no actual value for us to substitute. Instead, we have a full expression here. So this one's going to be a little bit more tricky, so follow along very carefully. We have the first term. The first term, T1, is equal to P bracket 1.01. Substituting this back here, so I'm going to write this down off to the side here. And this time I'm going to go vertically because you'll see that the expressions are going to get very long. So substituting this here, watch very carefully. 1.01 times P 1.01. So we substituted all of this here minus m. Expanding this, we get P bracket 1.01 squared, so multiplying this out, minus m. So this gives us T2. And there we have it. Now, being very careful now, I'm just going to substitute all of this here. Look and watch very carefully how this is substituted. Moving this along. So we have this expression substituting here. Take a look, I've left some space. There it is, 1.01 times T of n minus m. So substituting all of this inside, we get P 1.01 squared minus m. Expanding this out, we get, so expanding this, we get P 1.01 cubed minus, is that correct? Yes, it is, yep. M 1.01. So we expanded this minus m. And that answer gives us T3. Once again, taking all of T3 and substituting it back into the recurrence relation. So, getting rid of this, more space, we're substituting all of this back in. So we get P 1.01 cubed minus M 1.01 minus M. Expanding this out will give us T4, so I'm just going to write it straight away here. 1.01 times this, we get P 1.014. Multiplying it again, we get minus M 1.01 squared. Multiplying this out, we get minus M 1.01. So we're finished the expansion, minus M. And these are the first 4 terms of this recurrence relation. We could keep going, but this question only asks for the first 4. So I hope that gave you an insight into working with recurrence relations and understanding the expression itself. Hope to see you in the next video. Best of luck.